All right, let's have a look here. Are there any questions on that homework that's coming due? That'll be due on Wednesday, right? So it starts on 143, I think it is. That's that double projection problem, this one here. Okay. All right. And then, so we're good on 143. And then we did the position vector problems, 151. And then the one with the door there that swings down from the x-axis, you want to make a right triangle out of that to get the coordinate of b. And then the projection problems with the dot products. Okay. I did the one, and then there's another that you'll run through as well. Okay, you got any questions on any of that? Okay. We good? Is that all right? Makes the screen a little bit more visible. All right, so that's coming due on Wednesday. Now, one thing in Moodle that I do is down at the bottom there, I post the slides from the different recitations. I haven't posted the stuff from Wednesday. I've got a little behind, but I'll put the slides up there from Wednesday. I'll post them up there in Moodle. Okay, it's down at the bottom of the page. So that's there too, if you need it. All right. And of course, the recordings are there as well. All right. So we good with that? We got any questions? Good. Okay. Very good. All right, so we're doing equilibrium here, so let's keep having a look at that. So why don't we just kind of run through this one that we did again, just to kind of understand the deal here. So what we had a ring that was in equilibrium. And the cables are what's holding it in equilibrium. So the goal here, what we're trying to accomplish is find the masses, B and C, that are required to keep that ring in equilibrium. So a key part of this is to understand that the forces in the cable will equal the weights that are being hung there, and then B and C. And then once you know the weights, you can find the masses. So this is page 244. Okay, so that's the thinking on that. If you can find the forces in the cables, you can figure out what the mass at B and the mass at C are. All right, then the thing was to do there was to come up with a free body diagram like that. So we have the two forces in the cables, the one at B going up left at 60, the one at C going up right at 20 degrees. You have the weight of the ring, 39.2 newtons, and the spring force. Okay. And then you have two equations in two dimensions you can use. You can go sum of fx is 0 and sum of fy is 0. So those are the options you've got. So the setup on this is fairly straightforward. There is a fair amount of algebra on this to work through, so you have to work through some algebra, okay? So there's two equations you can use on this. Sum of fx is 0, sum of fy is 0. I usually, when I'm doing this by hand, when I solve it by hand, I'm going to do a substitution. So I want to solve with the simplest simplest equation first. And the simplest equation is sum of fx is 0. The reason for that is that then you don't have to include the weight of the ring and the spring force. So if you just go sum of fx is 0, you can directly relate fb to fc. Okay? So that was the reason for starting with that. All right. So sum of fx is 0 and what you want then are the x components. So you want the adjacent side, the side that's adjacent to the angle in both cases. So in both cases, you're using the cosine function to get that. FB pulls to the left. Cosine 60 FB will be negative. FC pulls to the right. So cosine 20 FC will be positive. You can work through the algebra on that and find that FB is 1.88 FC. Okay, so I'd start with that because that's the simplest relationship. Once I've got that, I'll then find the FYs, which are the opposite sides. So they're both sine functions. That's these ones here. Okay. So sine 60 FB, it's up, so it's positive, plus sine 20 FC, again, up is positive, minus the weight and the spring force is 0. Our equilibrium equations are based on summing things and getting 0. Okay. Again, we just work through the algebra there. We get 318.2 is 0.866 FB plus 0.342 FC. We have an expression for FB. It's 1.88 FC, so that goes in for FB right there. So now we only have one unknown in there. It's FC. So we can go ahead and work through that and solve for FC. It's 162 newtons. FB is 1.88 times that is 304. And then once you know the weights, you can divide by gravity and find the masses. That last step there is based on the fact that the weight is equal to the mass times gravity. So the mass then is the weight over gravity. And what G is 9.81 meters per second squared. So that's the process on that. Do we got any questions on that? All right. Okay. All right. So that's the 2D version of equilibrium. Now we can do equilibrium in 3D also, so why don't we have a look at that? Okay. So I have a page there, it's 248, and it just has the steps listed out. As I mentioned before, 3D I approach in a more formal way than I approach 2D. Okay? So 3D I can tend to walk through it in a very systematic way. And there's basically 3 steps. The first step is to write all the forces as x, y, z Cartesian vectors. Okay. The second step is to basically to build a matrix. Put the forces in columns, the rows then become x, y, and z. And those are basically the x, y, and z equations you're going to use in the rows. Set them equal to 0, and then find the unknowns. That's the steps. Okay. So on 250, I've got an example there we could run through. Why don't we have a look? So what I want to do, I've got 3 guy wires there. I've got the 9,000 Newton weight, and I have a force of the wind acting at the angle shown. And I want to find the forces in the wires. Okay. Now what I'll notice here is the wire forces, one goes in the negative y direction, the other goes in the x direction. There is one that just goes up here into 3 space. Why don't we get that coordinate there for that point where where the point C is, because one of those wires goes from O to C. Where are we there? We may be at negative 2, 1, 6. Is that it? Up there at C. So 2 back in the X, 1 in the Y, and 6 up in the Z. You all okay with that? Okay, so that's the coordinate there. All right. So the goal then is to get these forces as Cartesian vectors. Now, 4 of them are pretty straightforward. The wind, I have the angles that the wind makes with the x, y, and z axes. You can see those angular dimension arcs there connecting the forces to each of the axes. So alpha there is 74 degrees. That's to the x-axis. Then up to the y-axis, we got 17.54. And to the z, we got 97. So I can just go ahead and take the cosine of each of those angles times the 6,000 Newton magnitude, and I can get the wind force vector. There it is. Okay, the weight x in the negative z direction, so that's just 0, 0, negative 9,000. FA acts in the negative y direction, so that's 0 minus FA 0. And FB acts in the x direction, FB 0, 0. So I'll start with that. There's 4 of the forces. I've got 5 all told, but those are the easiest ones, okay? The weight and A and B all act along a given axis. Some of them are negative, but they're all right on the axes. And then the wind force, I've got the angles, so that's easy enough, okay? The one I will have to work through a little bit is the OC. It's that's an unknown, okay? So that's going like that. Okay. Now that's a pretty simple position vector because it starts at the origin. Okay, I don't have to do it. Saves the amount of work I might have to do. I mean, the position of C is the same thing as the position vector on this one. I don't have to do anything, involved to get the position vector of OC. It's just equal to that. I screwed that up, didn't I? So that is minus 216. I think I got that backwards. There we go. Okay, so I can just take that vector and convert that into a position vector, find its magnitude, divide through, get a unit vector, and scale it up by the unknown in this case, all right? So that'll be my next steps here. So we good with what's happening here? We got any questions? All right. All right, so from O to C, I take C minus O. Again, that's kind of a trivial step there because ROC is the same thing as RC. They're the same thing. It's minus 216. Square root of sum of the squares gets me 6.4. I'll divide through by that and get a unit vector and then scale that up by the magnitude. Now in the past, we've had numbers for a magnitude that we multiplied through those coefficients. This time we don't. We have an unknown. We don't know. We got FOC. I don't know what FOC is exactly, but I'm going to find out, okay? So what I do there is I multiply the coefficient. Each time I multiply the coefficient by that FOC, okay? So that gets me the last of the vectors I need. That is an unknown vector, but I do know its components, or I should say the coefficients in the x, y, and z directions. So negative 0.312 FOC, 0.156 FOC, and 0.937 FOC. That's based on getting the unit vector. So the idea there is I don't yet know its magnitude, but I know which direction it points. So I can use that. So you got any questions on that? Yes?
Why do you have to denote negative R sub O?
I don't.
The 0, 0, 0?
Yeah, the question is, why did I include the minus R0? The reason I did that is more from a teaching perspective. That's how you find a position vector. You take where you end up minus where you started. Okay. It's a trivial step, though, because you could have just gone with the position. Being as it starts at the origin, they're the same thing. But I just did it in a systematic way like I do all position vectors, so that's why I did that. It's unnecessary, though. Okay. All right. We're good? All right. So what I've done here, I've got expressions now for all 5 vectors. So what I'm going to do, I'm going to put them in columns. Okay, I'm going to put them in columns, and then the rows will then just become equations. I'm going to build a matrix is what I'm going to do. All right. Are we good with that? All right, so I'm just going to put each one of those into a column, into a rectangular matrix. And then I'll solve the matrix. That's how I'll solve this. See, what I have here is I've got 3 unknowns, OB, OA, OB, and OC. So there's 3 unknowns. I've got 3 directions, so this is solvable, all right? So I'll go ahead and do that. Everybody got this all right, or are you doing all right? Looks like I'm not doing all right. I got a low battery. There we go. All right. So what I'm going to do is I'm just going to drop all those into a matrix. So I set up the headings are the names of the vectors. So I put the unknowns first. I got FA, FB, FOC, and then the wind force and the weight. I put the force vectors in columns. All right, now when I do that, I'm going to have rows, X, Y, and Z. And those are basically equations is what they are. Because I know the sum of forces in the X is 0, the sum of forces in the Y is 0, and the sum of forces in the Z is 0. So by putting these forces in columns, I now have rows that represent X, Y, and Z equations. So that's how I would approach this. Okay, so what I'm doing there in green is I'm adding the stuff that I would put in there, what that really represents. So I'm putting plus signs between each of the columns, and I'm putting an equals 0 on the right. And I guess if I really want to get a little fancy here, I could add a little something on the left. I could just send a summation sign and an F to each one of those labels, because that's really what I'm doing, okay? Like that. So now what I have are 3 equations and 3 unknowns. Now these can be of varying difficulty. If you've learned how to solve out a matrix, you can use that approach to solve these. Generally speaking, on the homework and on a test or anything, I wouldn't give you a really hard one because I don't want you to spend all the time having to work through that. I'd give you one that's really straightforward to solve. So I would just, this can be solved in a pretty straightforward manner. You don't need to do a full matrix solution. You certainly could if that's how you like to approach them. That would be fine. You don't have to though. So this one here, what do we got? Right here, you'll notice there's only one unknown in that row. So sum of FZ is 0. It's 0.937 FOC minus 731 minus 9,000. So 0.937 FOC then is 9731. I can divide both sides by 0.937 and I can get FOC. It's 10,385. So I'll start with that one because it only had one unknown in it. Now, once I know what FOC is, I can start plugging that in for each one of these. Every time I see an FOC, I can just plug in the 10,385. So we're good with that. So now I know FOC is 10,385. I got some of FY. I'll do that one next because that has one other unknown. It just has negative FA. I know what FOC is now. So again, that row there, the sum of Fy, will only have one unknown. So it's minus FA plus 0.156 times what I found FOC to be, and that's 10,385. And then I got plus 5721, which is the wind force. So I go ahead and solve out FA at 7343. And then I can go to the top row, which is sum of Fx, and solve for FB. So if you preferred, you could do a full matrix solution on this if you liked. You don't have to, you know, whatever works is fine. So what you have now is you have the force in each of the wires, okay? So if you're designing that, you want to be sure those cables or wires or whatever you want to call them are strong enough to handle those loads. That would be the next step if you were doing the design on that. You got any questions on that? Good to go. Now you can express your answers differently just depending on what you want. If you want the magnitudes of the forces, you've got them. If you want vector solutions, you would just multiply those magnitudes by the unit vectors and get vectors for them. You could get either type of solution. Yeah.
What are the units to like the FOC and the FA?
All the units are newtons on this.
Okay.
They're all forces, so they're all
I just
newtons.
wanna make sure.
Yeah, sure. Okay. All right. All right, so there's the vector answers if you wish, okay? So I just take the magnitudes times the unit vectors. So FOA is 0 minus 73430. FOB is 158900. And then to get FOC, I take the 10385 times the unit vector, and I get that final vector. Okay, so there's an example of a 2D problem. So the first thing I did was I got the vectors into an XYZ format, which you call a Cartesian vector. I put them in columns. The rows then are sum of Fx, sum of Fy, and sum of Fz, and I solve out those equations and solve for the unknowns. So what I have then is I have the magnitudes of the forces, and I can get them into a vector form if I like. Got any questions on that? All right. Okay. All right, there we go. All right. Well, let's see. Sounds like y'all can do that, so you two can do 3D equilibrium problems. How about 253? Now this one's a little different here. I can't remember, I think I started that. Yeah, how about getting F1 first? So let's get an expression for F1. Let's start with that. This is 253, it's the notes of your book. So start with a vector expression for F1. Yeah, so everybody good on the coordinates there? Yeah, -3, 6, okay? Because that 3 is going back that way. Okay. And then get a unit vector once you've got that. And then just multiply the 4,000 through. You want to find the length of that vector? Right, yeah, it's coming from 0, 0. So this one's a little simpler than some of the ones we've worked on before. The fact it starts at the origin simplifies it quite a bit to find the position vector. Then you take the square root of some of the squares to find the length. You've got the vector. So you're going to find, take this square up 2, square up -3, and square up 6. Add them up and take a square root. That'll get you the length. And you want to divide that out. That's how you get a unit vector. Okay. It's on the square. That is the magnitude, so that's the magnitude of that vector, is the length of it. No, you're gonna, well, what you do next is you divide it into that, right? Then multiply it. And if you've got questions, let me know this way.
Something is missing. Oh, that's true. Okay. Does that go to like the website? Does it go to
I would just
okay.
How is this button?
All right. Remember to watch your signs when you carry the unit vector through. It's common to drop signs, so we don't want to do that. So there's only one of them to watch, but keep an eye on them.
Should we define the angle between the curves?
You don't need it. You just need a unit vector. What's that? You don't need angles,
Do
no.
we need angles between axes?
No,
Okay.
not required. When you got position vectors, you can just skip the whole angular part, because you can get a unit vector directly.
I mean, so the cosine of all of the components of the unit vector give you the angles between their respective axes.
Inverse cosine.
Inverse cosine, perfect.
Yeah, but it's not always
But they don't
necessary.
have it.
Right, often you don't. Okay, then once you got the unit vector, so you're going to find the magnitude. It's the square root of 49, which is 7, right? You're going to divide through by the magnitude to get the unit vector. All right. So there's, we're doing all right on F1? Doing okay? F1? Yeah.
We can only really make unit vectors for F2, 3, and 4 though, right?
Okay, so we got the position, we take the square root of some of the squares, we get 7, we divide it by 7, and we scale it up by 4,000. And so we get F1, 1143, negative 1714, and 3429. You doing all right?
Yes.
Okay. All right, now we got to figure out those unknowns, right? So we've got the unknown vectors that we need to work on. Okay, so we good with F1 here? Everybody got that? Okay. All right, let's look. Why don't we look at one of them, then we'll go. You can do the other. So let's look at F2. Okay, now F2 goes, it's in the XZ plane. Okay, now again, this is that reading the dimension lines. This dimension line here is parallel to the Z axis. So we're coming off the Z axis, the X axis, and going in the negative Z direction. So this plane is in the XZ plane, or this point, I should say, is in the XZ plane. Now, a mathematician would call that, what, the Y plane, but I don't like that doing that, so I call it the XZ plane. Okay. Now, we've got another one here, too, that kind of reinforces that. We've got this line here, which is parallel to the X-axis. So that's coming off the projection of the Z-axis in the X direction. So that's telling us doubly that we're at that point is in the XZ plane. We good? So once you have that information, you should be able to come up with alpha, beta, and gamma. Okay, alpha is the angle with the x-axis, beta with the y, gamma with the z. Okay. So that point there, so I guess I would say F2 is in the XZ plane. That's what I would say. Okay. So what's alpha going to be there? The 27 degrees for alpha, because it's shown there, right? Now beta is based on the y-axis, which is normal to the XZ plane. So if that vector is in the XZ plane, it's going to make a 90-degree angle with the y-axis. You just think of that plane as being like a wall. The y-axis is normal to the wall. It doesn't matter where that vector is on the wall, it's normal to the y-axis. So that's a 90-degree angle. And then gamma, well, it's nice to have a sketch. So this 27 degrees and this right angle are coplanar. So you can add them. So that'll be 117. That's equal to 27 plus 90. Okay, so there's alpha, beta, and gamma. Well, those are just angles. Then to get a unit vector, you take the cosine of the angles. So you start with the angles, then do the cosine. Good. Yeah. The 90 comes from the fact that I've got, so as I look at it, let's say I'm looking at it from this perspective. I'm looking down the y-axis. If I'm doing that, what I'm going to see is I'm going to see something like this, x and z. And then that vector F2 is down like that. And that makes a 27-degree angle. So in this sketch, the y-axis comes out of the board. And it doesn't matter where that thing is. If it's on the board, it's going to make a 90-degree angle with that y-axis. So that's where the 90 comes from. All right. So to get F2 there, I'm going to take F2 times that unit vector, which is the cosine of those angles. So that's going to be F2, which is an unknown. I don't know what it is yet, times cosine 27 times 0, because that's the cosine of 90, and then times cosine 117. So I got alpha is given there at 27, beta is 90, and gamma is 117, which is 27 plus 90. Okay. So I just take the cosine of those three angles, and that gets me my unit vector. The cosine of 90 is just 0, right? So where that comes from is I'm taking the cosine of 90. Okay. So that gets me an expression for F2. Now I don't know what F2 is yet, but I know it's proportions. Okay. So how about doing F3 next? It's similar to this one in the approach anyway. Okay, so there's a better look at F3. Of course, you have it on your page, so you should be able to use your paper to kind of figure it out. That's in a plane also, so I think you're going to want to start by identifying which plane you're in. Yeah, that's correct. So if you know which plane it is, which is the YZ plane, you should be able to figure out the angles that it makes with each of the axes there. Okay, so figure out alpha, beta, and gamma for F4. Or excuse me, F3. I'm sorry, F3. What do you got a guess for alpha? That's 90, right? Beta, 38. Gamma, 128. That's 30, because it's coplanar. The 38 is coplanar with the right angle between the axes. Okay. So then you just factor the unknown F3 through the cosine of those angles. Okay. We're good with that? So we don't know what F3 is, but we know these angles. So cosine 90, cosine 38, and cosine 128. And then from that, you can get F3. And, yeah, okay, so we've got 0.788 times F3, and then we got 128. Take a cosine of that, it's negative 0.616. So that's F3, okay? Doing all right? Now how about F4? What's that going to be? Now, if you're not given, if you've got a line that looks like it's in line with something else, you're not given any information about it, you know, you can infer which way it's going. So which way is F4 going? Yeah, so negative F4, 0, 0. That's all you got to do on that one. Now, that's just a convention. If it's drawn and it looks to be collinear, and there's no other dimensions on it to tell you otherwise, you can assume that it is collinear. So it's negative.
Negative cosine of 0, right? Called negative 1, 0, 0.
If you wanted to, yeah. Yeah, you could.
Unit vector.
Right, you could do that unit vector thing. So it'd be F4 minus cosine, it'd actually be 180, yeah.
Yeah.
Cosine 180, cosine 90, cosine 90 is actually what it would be.
Oh, yeah.
Thank you. All right. So now we got the vectors. What's the next step here once you got the vectors? Yeah, build a matrix, put the vectors in columns. The rows then become the equations. Okay. So just get that built. So just put each one of those forces in a column. Yeah, and it's a matrix is what it is.
Let's just do matrices stuff and calculate the question for you. Probably for our
Okay, so something like that. And then you just solve the matrix. Now, if you want to, if you want to solve that matrix style, if you got a little stuff you can push on your calculator on homework to make that happen, that's fine. You could also just do these manually. If you're gonna, if we're gonna do this manually, which one's the first equation to solve? You're looking for one with one unknown. And yeah, I think I heard a z. You all seeing that? See, that's an equation. What that is sum of fz is equal to 0. That's what that equation is. So what you've got there is 3429 minus 0.454 times f2 is 0. So you can then say 0.454 f2 is equal to 3429. And then you can divide out.
Why do you start with F? Or do you Z?
Z. The reason I'm starting with Z is I only see one unknown in that row. You could just as well start with y on this one. The only one you don't want to start with would be x. You know, if you're solving this manually, you pick a row that has one unknown. Okay? Now, if you're doing a vector style, on the matrix style, you just solve it and make it here.
Isn't there a Z component for
No.
Yeah.
But it was.
Yeah.
I'm sorry, my bad. I got in a bit of a hurry. I screwed up. So what did I screw up here? So this is F3. It has a negative Z, so I put the Y where the Z belongs. Is that correct? I think I did. Yeah, I did. Man, I really screwed this one up. I'm sorry. Everything's one row too high, so my bad. There we go. I just had stuff in the wrong place. And that's going to change how we have to solve this in there. So thanks for calling that out. I made an error on that. So there we go. That's looking better. Right? Is that good? Okay. My bad. Okay, so now my advice is wrong because what row would you start with now if you're going to solve it manually? Yeah, Y. Okay. Because it only has one unknown. It has F3. So sorry about that. But F2 is zeroed out. Okay. So if I'm going to go sum of Fy and set that equal to 0, all I'm going to have is negative 1714 plus 0.788 F3, and that'll be 0. So 0.788 F3 is equal to 1714. And then I can go ahead and get that. So 1714 divide by 0.788, 2175. All right. So once you know what F3 is, you could solve the Z row now. You could also solve the X row. Okay. Well, I guess you do Z next, wouldn't you? Sorry, let's see. So what do we got here? We're going to do the Z. So, disorganized here, but here we go. So sum of FZ. There we go. So what do we got for FZ? We've got 3429. Minus 0.454 times the unknown F2 minus 0.616 times the 2175 that we just solved for. So given that, you should be able to solve for the one you're after. We could take the 0.454 F2, and that's going to be, I'm going to take that to the other side of the equation so it will become positive. And that'll leave 3429 minus 0.616 times 2175. 1340. So 0.454 F2 is equal to 2089, I think. So we'll divide that by 0.454, and we'll get 4602. Okay. And that gets you F2. And then the last unknown is F4. So you just work through these systems of equations. We're doing all right with that? So there's the last little solution there to get the last one. Okay?
And then you want us to multiply those newtons back onto the unit vector?
It would just depend on what I'm asking for. And this one, I did that, yeah. If I'm just saying magnitudes, you don't have to. It just depends on what the question specifically wants. Okay, okay, so there you go. So that's why we multiply through. Okay. All right, why don't I get you one of these to do for next Friday? Remember, we don't have any school on Monday. go. How about doing 182? It's on page 6A. So that's due Friday. And that is the 24th, is it? I think so. All right, and what else did I assign? Was it 171 and 173? Is that correct? Okay. So that's the list for Friday.
What was the number again?
For what?
The one that you're signing right now.
It's 182. It's on page 6A. So 182 is on page 6A. And then also 171 and 173. Okay. Good to go? Questions? You all right? Okay, it's all good.